Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on February 11th, 2026, just yesterday. It introduces PhyCritic, a new multimodal model that achieves significantly higher accuracy on physical reasoning tasks by using a novel solve before judging training strategy. The paper is titled PhyCritic, Multimodal Critic Models for Physical AI. And as we'll see later, this approach has really impressive implications for making AI more reliable in real-world physical environments. Figure 1 illustrates the core solve-before-judging mechanism that distinguishes this approach. On the left, the system receives a sequence of images and a question about cooking vegetables, along with two candidate answers from other models. Instead of immediately rating them, PhyCritic first generates its own internal solution in the blue panel, explicitly reasoning that the oven door is already closed. It then uses this self-generated insight to evaluate the options in the green panel, correctly selecting response 1 because it aligns with the physical reality of the scene. To achieve this, Figure 2 details the two-stage training pipeline used to build the model's capability. On the left, Stage 1 is the physical skill warm-up. In this phase, the authors use group relative policy optimization to train a base model purely on answering physical questions, establishing a strong foundation of reasoning skills. Moving to the right, Stage 2 performs the self-referential critic fine-tuning. The diagram shows how the model first generates pred think tokens to solve the problem itself, and then critic think tokens to judge the candidates. The final reward combines points for both the solution and the critique, forcing the model to align its evaluation with its own internal logic. Table 1 explicitly lays out the prompt used for this fine-tuning. It starts by defining high-level criteria, including truthfulness, visual groundedness, and logical validity. However, the most important mechanism appears at the bottom, highlighted in green. Here, the prompt forces the model to follow a strict sequence. First, it must write out its own reasoning and answer using prediction think tags. Only after solving the problem itself is it allowed to generate the internal monologue for comparing the two external responses. So, does this rigorous prompting strategy actually pay off? Table 2 provides the answer, benchmarking the model against both proprietary giants and open-source peers. The top section shows commercial models like Gemini and GPT-4o setting a high baseline. But looking at the open-source section below, PhyCritic 7b achieves a remarkable breakthrough. In the PhyCritic bench overall column, it hits a score of 68.0, far surpassing the 51.6 of its base model, QN 2.5 VL. It even outperforms GPT-4o on these specialized physical tasks. And importantly, the columns on the far right confirm that this focus on physics doesn't hurt general performance, with gains visible on the versus L reward bench as well. Okay, while the last table focused on judging, Table 3 asks a different question. Does learning to critique make the model a better problem solver? Here, the authors evaluate PhyCritic as a policy model, meaning it must generate the solution itself rather than just grading others. Looking at the Cosmos Reason 1 bench in the first section, the model achieves an overall score of 63.9. This is a major jump over its base model, QN 2.5, which scores 54.3, and it even outperforms GPT-4o. The gains continue in the EgoPlan Bench 2 columns on the far right, where performance rises to 42.3, proving that verify-based training effectively transfers to downstream execution. So while Table 3 showed the model generating its own answers, Figure 4 asks a different question. Can it recognize the best answer among many? This chart tracks the performance of best-of-n sampling, where the system generates multiple options and a judge picks the winner. The blue line representing PhyCritic as the judge climbs steeply, starting from the base accuracy of 54.3% and reaching 60.8% at 32 trajectories. In contrast, the other lines, like majority voting in orange or the base QN model in green, stay mostly flat or improve very slowly. This significant gap confirms that PhyCritic isn't just lucky. It genuinely knows how to distinguish correct physical reasoning from plausible-sounding errors. Wrapping up, two key takeaways really stand out here. First, the solve before judging approach demonstrates that to effectively evaluate physical reasoning, a model must first understand the physics itself. Second, this training creates a virtuous cycle where learning to critique actually improves the model's own problem-solving skills. This offers a promising path forward for building more reliable, autonomous agents in the real world. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.